So dividing a polynomial by another polynomial, in this case a binomial, is very similar to performing a division of numbers using long division. So what we're going to do is we're going to illustrate how to do this by solving this example, and then we're just going to repeat the processes with other examples. So let's say we're asked to divide x cubed plus 13x squared plus 39x plus 46 by x plus 9. Now I'm going to label a couple things here so that when I refer to these terms in the process, you'll know what I mean. This over here is the divisor. And then this over here is the dividend, meaning we're dividing this into this. The number or the result that we're going to get in place at the top of this bridge over here is called the quotient. The first thing we're going to do is we're going to divide the highest degree in the dividend by the highest degree in the divisor, and this will be the first term in the quotient. So what we mean is we're going to take the highest degree, in this case that's x to the 3 in the dividend, and divide it by the highest degree in the divisor, which is x over here. So on the side I go x to the 3 over x, and that is going to equal x squared. So what I do is I take that and I start off my quotient with that term. Next, we're going to multiply the quotient by the divisor and then subtract the result from the polynomial. So I have x squared on the side once again, and I'll do this in a different color. I'm going to go x squared multiplied by x plus 9. When I FOIL this out like this, I end up with x cubed plus 9x squared. So what I'm going to do is I'm going to take this result here and we're going to subtract it from the polynomial or the dividend. And so I'm going to write it in green here, minus x cubed plus 9x squared. What I want to be sure that I do is I'm going to make sure I line up all the exact variables right underneath each other so that we can actually add or subtract. So when I do this, I can see that the x3's cancel, so I'm left with 0. 13x squared minus 9x squared gives us 4x squared. Now with this value, we're going to repeat the process. The final step, until we start repeating it, is that we're going to bring down the next term in the dividend and repeat the process, that's 1 and 2, until there are no terms left. So I'm going to bring the 39 down here, so it's plus 39x. And then what I'm going to do is I'm going to repeat the processes 1 and 2, and I'm going to keep doing this until there are no terms left. So I'm going to divide 4x squared by the first term in the divisor. And so when we go 4x squared divided by x, that is going to give us 4x. So we're going to take this, like we did previously, and we're going to put it as another term in the quotient. And then just like we did previously, we're then going to take this term and we're going to multiply it by the divisor. So we're going to go 4x multiplied by x plus 9. And when we do that, we end up getting 4x squared plus 36x. So now what I'm going to do is, like I did previously, I'm going to subtract this value by whatever's left in the polynomial, which would be this right now. So we're going to go minus 4x squared plus 36x. 4x squared minus 4x squared gets rid of this. We got 0. 39x minus positive 36x gives us 3x. And then what we're going to do is we're going to bring the term that's next to it or left over, which is the 46 down, plus 46, and then we're going to repeat the process. And by that, we're going to divide the 3x by the first term in the divisor, which is x, and that's going to give us 3. So we're going to place this 3 as a term in the quotient. And then that 3, we're going to multiply it by the divisor. So it's going to be 3 and then x plus 9. And that gives us 3x plus 27. We're then going to take this result and we're going to subtract it from whatever's left in the polynomial. In this case, it's 3x plus 36 minus 3x plus 27. The 3x is canceled. And then 46 minus positive 27 gives us 19. And since there are no values left to bring down, this concludes the process, and this is the remainder. And so the division is complete. We can write it like this, where x cubed plus 13x squared plus 39x plus 46 is equal to x plus 9 bracket multiplied by x squared plus 4x plus 3, which is the quotient, plus 19, and that is the remainder. So it can be written like this. Let's do another example. So for our next example, let's divide 2x cubed minus 3x squared minus 8x minus 3 by 2x plus 1. And once again, remember that this is going to be the divisor. Okay, and then this whole thing here is the dividend, okay, or the polynomial. So we're going to repeat the process that we used for the first. So I took the head coefficient, or the lead coefficient of the dividend, and I divided by the leading coefficient, or degree of the divisor, and that gave me x squared, and I put that as the first term in the quotient. Now I'm going to take the x squared, I'm going to multiply it by the divisor, 2x plus 1. And then that is going to give me 2x cubed plus x squared. I'm going to then take this value and subtract it after carefully lining up all the like terms. That would then cancel the x cubes, and then minus 3x minus x squared gives me a value of minus 4x squared. And then we're going to repeat the process, starting, of course, with this one here. Dividing minus 4x squared by 2x is going to give us minus 2x as the quotient. And then we're going to take this and multiply it by the dividend, and it's going to give us minus 4x squared minus 2x, and we're going to subtract this here. But before we do that, remember, bring the term down, so minus 8x. Now we're going to go minus 4x squared minus 2x. This is going to cancel the 4x's over here, and then minus 8x minus 2x is going to give us minus 6x. And then we're going to repeat the process until this is all complete, or until there are no other terms in the polynomial. And so after completing this and bringing everything down, we get a remainder of 0. So then we can finally write this, that 2x cubed minus 3x squared minus 8x minus 3 is equal to bracket 2x plus 1, and then another bracket x squared minus 2x minus 3, and then there is no remainder, it's plus 0. And so this is the final division sentence over here. Okay, now this one's a little bit different because we appear to be missing a term. So it says divide x cubed minus 10x plus 6 by x plus 4. And we see that it goes from x cubed all the way down to x. Now, when that happens, what you're going to do is you're going to insert a 0 as a coefficient and then x squared, because we should have a set topical order from the highest degree to the lowest degree. So insert the 0x squared. So what we're going to do is we're going to set this equation up as per usual, x plus 4. And actually, let me give myself a little bit more room here. We'll skip a line, x plus 4 divided by x cubed minus, or plus, it doesn't really matter if you write minus or plus, so plus 0x squared minus 10x plus 6. Now that we're here, we're going to do the regular process. Now, you may have noticed that with the past 3 examples, we've made it a point to include the remainder in our solution. And that's because the remainder is actually highly significant. When we're dividing a polynomial by a binomial in the form of x minus a, so that a value would be whatever the x value is set to 0, right, or whatever the factor that we're dividing it by. The remainder is f at a, meaning that if we plug in the a value into our function, into our polynomial, the remainder is going to be the output of that function. So when I write f at a here, I'm really talking about the output, or the y value, or the solution. Now, if the remainder happens to be 0 when dividing by a binomial, then the x value in that binomial is a factor, right? Or it's one of these zeros, or one of the roots, okay? So when we say factor, we could be referring to zeros, right, where the y is equal to 0 and it crosses the x-axis, or the x-intercepts, or the roots. These are all synonyms, okay? They mean the same thing. That being said, the remainder theorem provides us with one way to factor higher degree polynomial. So let's say we're asked to find out if x minus 5 is a factor of the polynomial f at x is equal to x cubed minus 6x squared plus 3x plus 10. The strategy that we're going to use is we're going to divide the polynomial by the binomial. So we're going to divide this one here by the binomial x minus 5. And we're going to get the remainder. And this is going to be using the exact same process we did for the 3 previous questions. And then now we're going to look and see what the remainder is. If the remainder is equal to 0, then we can say that it is a factor. If it does not equal 0, then it is not a factor. So first, let's use long division to get the remainder. So here we can see that we end up with a remainder of 0. So since, and I'll just write here, since, okay, x minus 5 gives us a value of f at positive 5 to equal 0, then x minus 5 is, and I'm triple underlining here, a factor.